What up, mathletes? Woo-hoo! All right, day 2 of this lesson where we're talking about the shape of graphs. We're going to talk about relative high and relative low points today. And let's look down here. I want to look at this graph. I need to zoom out just a tad so we can see everything I want to see at one time. So we can use the sketch to examine the behavior of a function and qualities of relative high and low points, and then complete the exercises of points A and C, or complete the exercises. Points A and C are relative high points of the graph, and point B is a relative low point. What a relative high point means is that to the left, I'm increasing, to the right, I'm decreasing, whereas, and we'll talk about that more, a low point means to the left, I'm decreasing, but to the right, I'm increasing of this. We're going to talk about that more in just a second, but let's go down here. So what's extra one? It says drag point P along the function A, note the changes in its, or to A, noting the change in the y coordinate. What happens to the value of P as it approaches A from the left? Well, look at P. So we see the y value is 9.29 right here. If I go up, what's happening? As I'm approaching A, that value is getting bigger. And then as I go past A, what's happening? That value is getting smaller. So what happens as it approaches from the left? The y increases and decreases as it moves to the right. Boom. That's what's happening. Exercise 2, drag the point P along the function to C. Okay, let's go to C. As it approaches C from the left, and as it moves away to the right. How does this compare to what's happening to A? Well, the same thing. Look, as I approach C, the y value is increasing. We see that right here. Here's the y value. And as it goes past C, what's it doing? The y value is going down. 4, it's going down even more to 2, all the way right into negative values. So, it is the same. It is increasing as it approaches C from the left, and decreasing as it moves away from C to the right. Yeah, there we go. Our last exercise is probably going to ask about B. How about let's check out B. What's happening at B? Well, as I approach from the left, what's happening to my y? It's 7 right now, and I'm getting closer to B. Now it's even lower to 1. And then what is it? Right, it gets lower and lower and lower until it hits B, and then as it moves away to the right, what happens to that y? We see it. Sorry, I keep trying to jump to the other side. But y is getting bigger and bigger and bigger. So this is the exact opposite. As P approaches B from the left, the y value is decreasing. And as it approaches, or I'm sorry, moves away to the right, the value is increasing. Awesome. This is how you would answer questions like this, okay? We can kind of see what is happening. You don't need to write all this down. I just want to make sure you understand what's going on here and to answer questions of this nature. All right. I'm going to reset this resource and move on. Let's talk about the extrema of graphs. Remember, the extrema is just a collection of relatively high and low points. We just looked at a few there. We had 2 relative high points, and we had 1 relative low point there. So a function is increasing where the graph goes up and decreasing where the graph goes down when viewed from left to right. So we view it from left to right, correct? So as we're doing that, it says use the slider to reveal details, but I actually want to draw this, and then we can look at it with the slider. So as we go from left to right, what do we notice the graph's doing? I'm going to use red to represent decreasing, so it's decreasing until we get to this point right here, And then I'm going to use green to be increasing. And then we start increasing till this point. And then as we keep going right, it's decreasing. Oh, that was the wrong value. It's decreasing again. So these are special points we're looking at right here. The point where it changes from decreasing to increasing, that's going to be called a relative minimum. That is terrible writing, but go with me. Relative minimum. And then we have the point where it goes from increasing to decreasing. It's that top of the hill. So this is the bottom of the valley. This is the top of the hill. That is called a relative maximum. And the reason we say relative is because these are, like I said, valley and hilltop points. But if you look to the left, it started out a whole lot higher than this relative maximum. And if I look to the right, it's going to get a whole lot lower than this relative minimum. But we're talking about just special points of interest where we see kind of the change in the guard, where it goes from decreasing to increasing, back to decreasing again. And if you see me use words like I use maximum, if you ever read the word like maxima, well, there might be more than one relative maximum point, so that'd be the relative maximas, right? It's plural. Or the minima, that's plural for minimum. Okay, so just keep that in mind. All right, I'm going to erase this, but let's go ahead and move the slider. You see the same thing I just pointed out, right? Where it's decreasing, increasing, decreasing, okay? And down here, we call those points the relative minimum, and again, the relative maximum. If f of x has a relative maximum when x equals 2, then is f of x increasing or decreasing as x approaches 2? Well, if it's a maximum point, we're always increasing as we approach it and decreasing as we leave it. The opposite of that is if it's a relative minimum, we're always decreasing as we get to a relative minimum and then increasing as we leave it. Okay? Good points to know. Okay. So determine increasing and decreasing parts of the graph and function. Just looking at this, it has stuff for us to tap on, but really we can just draw our own, right? So again, where is it decreasing? Well, if I'm going from left to right, it's decreasing, 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 decreasing until I get to the y-axis. Then what happens at that point? It begins to increase, 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 increase. Boom. So we see that we have a relative minimum. So remember, if it's decreasing approaching it and increasing afterwards, then that would be a relative minimum. And that point occurs here on the y-axis. All right? It's good stuff. Just exploring the shapes of these graphs. Determine extrema of the graph of a function. So extrema includes all the minimum and maximum points. So it says select all the points that are relative maximums. We want the points that are the high points. Well, clearly that is B, D, and F. So B, D, and F. Boom. That's it. It's not bad. We can answer questions like that, right? Okay, watch this animation. We're going to talk about a comic book store. Watch what a comic book store does when determining pricing of comic books.
Mr. Wynn and Miss Berg manage a comic book store. Looking at the store's financial records, Ms. Berg sees that the store made $75,000 when they charged $5 per issue. Mr. Wynn points out that the store earned $80,000 when issues only cost $4. Ms. Berg assumes if they lower the price to $3 or even $2, the store will make even more money. Before Ms. Berg could change the prices on all the comics in the store, Mr. Wynn shows her a graph on his tablet. He explains that they have tried many different price points in the past, but $4 seems to have the best earning potential based on the model.
Okay, I zoomed in a little bit so we could look at this graph. Notice what's happening here. He has a graph of earnings in thousands over cost per issue. And it's a parabola facing down. And what we see is the earnings are increasing as you increase the price up until it hits $4. Then once you pass $4, there's a tipping point. People are like, no, it's a little too expensive. And stop. Now, the reason why so that's the sweet spot where you have the maximum amount of people buying and paying the maximum price is going to be about $4 from that information he's seeing. Whereas it shows the problem is when you charge less, you have to sell more. And if not enough more people are buying it, it's not worth charging less. So that's where businesses start getting their pricing points depending on not only what people are willing to pay, but how many people are willing to pay that, right? You may have more people paying for less, but if it's not enough more, it's not going to make you as much money, which is the goal of good business. I like money. I want to make money. So to determine whether D is a relative minimum, relative maximum, it's a relative maximum because we're increasing up until that point, decreasing after that point. Okay? What's a question? Does this function have relative minimum? No, it doesn't, because we see it goes clear down to 0, right? They're going to make zero money at $0, and then once they get up to charging $8, they go back down to making 0 because ain't nobody buying those for $8. Some of you are probably thinking now, man, I'd love to pay $8 for comics. They are stinking expensive. They are. Goodness, they went up in price. Okay. Just got to wait and determine some things about another graph. So now we're going to talk about end behavior. End behavior, a lot of people think, oh, the end's on the right side. It's at the end, like the end of a book, the end of a sentence is always to the right. Well, end behavior explores both ends. There's two ends to a line or a function, right? We're going to explore the left side. And what do we see on the left side? As you move to the left, the value is decreasing, which means as x decreases, because it decreases going left, y also decreases. Conversely, as you move to the right, as x increases, y increases. So what is the end behavior of a linear function when the slope is positive or negative? Well, this is a positive slope. It's going up from left to right. And we see, again, as x decreases, y decreases. As x increases, y increases. But what if it's opposite? What if our slope is negative? That is a terrible line, but we're going to go with it. So what if we instead have a negative slope? Well, what do we see of our end behavior? We see as x is decreasing, y is increasing. So as x is going down, our y is going up. And again, the opposite, as x is increasing for a negative slope, our y, that x looks too much like a y, is decreasing. So again, this is for a negative slope. And we know it's a negative slope because it's going down from left to right. Over here we have a positive slope. It's a positive slope over here. You didn't know that's the difference between negative and positive slope. Now you do. Awesome. All right. Now we're going to determine the end behavior. This will be our last example of the day. So what's happening here? Whoa, what is happening? Good night. Boy, fix that. This was all freaking out. But anyway, so let's look at this graph right here. What's happening at the end? So if I look over at this end, what's it doing? Well, we see that as x is decreasing, right? As x is decreasing, we see that our y is also decreasing. And then let's look on the other side of it. As x is increasing, what do we see our y doing? Y is increasing. We're just talking about the end. Some of you may be looking at this middle part saying, well, there's some differences there. We're talking about the end behavior. So this end behavior right here and the end behavior down here. So we see again, as x increases, y increases. That's true. As x decreases, y decreases. That's also true. So this is going to end up being A. Whoa, what happened? That's right. Let's get out of here. That's it. Don't have a seizure and peace out. Still recording? Oh, yeah. Ah.